Why waste time in commute and spend lot of money for iitjee coaching? Parents, do you want your kids to achieve top scores in iitjee? India's leading online NEET coaching 100% success iitjee. At TeenEinstein, we focus on iitjee coaching from Class 6 to Class 12. We think you'll like it. Our teachers are mostly PhDs in physics, maths, chemistry, botany, and zoology, with lots of years of teaching experience for Class 6 to Class 12. Thousands of videos, quiz, MCQs. We provide a daily worksheet of 30 questions on each topic: math, physics, chemistry, and biology, for rigorous practice, concept understanding, evaluation, quiz, and thousands of videos. Limited offer 40,000 rupees per year. Book your class. TeenEinstein.com.
Hello students, welcome to the POIQ discussions on JEE Advanced paper. Here I have got a problem from JEE Advanced paper 1 2023. So this problem says a thin conducting rod Mn of mass 20 gram, length 25 centimeter and resistance 10 ohm is held on a frictionless, long, perfectly conducting vertical rails as shown in the figure. So let me explain you this. So these are the vertical rails. These are perfectly conducted and long. Okay, these are rigid also, frictionless. And there is a thin rod Mn which can slide over these rails. There is a uniform magnetic field B0 which is equal to 4 Tesla is directed perpendicular to the plane of the rail rod arrangement. So if we take this rail rod arrangement in the plane of the paper, then magnetic field is perpendicular to the plane of the paper and it is coming out of the plane of the paper, which is represented by the dot inside the circles here. The rod is released from rest. This is important. At t is equal to 0, the rod is released from rest. It moves down along the rails. So it moves down along the rails like this. Okay. Assume air drag is negligible. Match each entity in list 1 with an appropriate value from list 2 and choose the correct option. So these are the options you have to choose after matching the correct option. Okay. Given acceleration due to gravity is g is equal to 10 meter per second square and e to the power minus 1 is equal to 0.4. So these are the necessary or useful informations given here. So you have to find out these entities. Okay, P, Q, R, S. So let us see what are the entities we have to calculate from this problem. See, at t is equal to 0.2 second, the magnitude of the induced EMF. That means I have to find out induced EMF. Second thing, at t is equal to 0.2 second, that means at the same time, the magnitude of the magnetic force in Newton. Okay. At t is equal to 0.2 second, the power dissipated as heat in watt. And last option is, like last question is, the magnitude of the terminal velocity of the rod in meter per second. Look, I'll just explain one more important point over here, so which you need to consider during solving this problem. So what is the concept? See, this is obvious that this is a problem of motional EMF, and you know how motion happens. See, when it is released from rest, see, since it has certain mass, it will try to move down due to this gravity. Okay. At the same time, you look, the EMF produced over here will try to pull it back in this way. Okay. So I hope you have understood how the EMF is coming from here, like coming in this situation. See, this is the area, effective area between this current lobe. Okay, you can see that. Alright, so when it moves down, the area changes, right? Area changes means the flux passing through this loop will be also changing. Therefore, there will be change in the flux. And wherever there is a time varying flux, there will be EMF induced. Okay. And see, induced EMF will actually oppose the cause of the production of EMF. That means it will oppose the motion of this. Okay. That means magnetic force will be actually pulling it up against the gravitational force, right? So you will see there will be two forces. One is gravitational force, I mean the force due to gravity, which will be mg downward, and there will be a magnetic force in the upward direction. Okay, since there will be current flowing in this loop. Okay, so current will be flowing in this rod in this direction. Okay, if you just do this carefully, the right hand thumb rule you apply, then you will get the direction of the current which is flowing in the circuit will be this way, so that the magnetic force will be in the upward direction, right? So there are two forces, and see this force, the weight of this rod will be greater than this magnetic force initially. So this will actually come down. So as it is coming down, the EMF also will be increasing as the area, effective area or the effective flux change will be more and more. Therefore your magnetic force also will be more, because see, magnetic force here on this conductor, on this Mn conductor will be IB0L. So this will increase when EMF increases. Okay, and see, there will be a time when eventually this mg will be exactly equal to the magnetic force. So this, at this situation, there will be no net force acting on this rod, and it will come down or fall with the terminal velocity. So this is the whole situation over here. So now first question, if we look P, we have to find out the magnitude of the induced EMF. So as we know, motional EMF is BVL. Okay, so I have to see what are the information we know here. I know B is equal to B naught, which is given as 4 Tesla. Length is also given, but what is not known is the velocity. Velocity at 0.2 second we have to find out. Now this is my main task here, and this is the whole point over here. Rest of the things will come easily. Okay, so to find out this velocity, you know what we have to consider? We have to consider the motion of this Mn rod. I have to draw the free body diagram. See, here there will be two forces as I mentioned. One is due to gravity, another one due to the magnetic force. Okay, due to the magnetic field. Okay, so this magnetic force will try to pull it up, while this force due to gravity or the weight of this rod will try to pull the rod down. Okay, so here you look, this magnetic force IB0L, again I can write, see, the resistance of this conducting rod is given as R. So I can write down the current on that, the current passing through that. That is, see, EMF by R. If we put it here, the magnetic force is E by R V0L. So I have got these forces, and see, as I said, this force initially will be greater, so that you will get a net force in the downward direction, and that force, let us say MA, which I can write as Fg minus Fb. So Fg is mg, and this Fb, that is magnetic force on the conductor, is E by R V0L. So from here I can get acceleration if I just divide with the mass. Now look, I have to find out velocity, right? I have to find out velocity at any instant of time t. So for that I can write this acceleration as dv by dt, and in the right hand side, see, instead of writing E, I can write BVL, because there also velocity term is involved, right? So ultimately I get this, you look, this one, dv dt is equal to G minus B naught square. If I put this E is equal to B0 VL here, then I'll get B naught square L square V by MR. Okay. Now see, if I have to find out velocity, then I have to integrate this equation. You look, this is the thing now. Okay, I have to integrate it. Let us say the time is, see, it is starting from rest. So at t is equal to 0, the velocity will be 0. At t is equal to t, let us say the velocity is v. Now if we integrate this, see, left hand side integration of time will be t only, and this is the matter of calculation. Now you can see you have to integrate this term. So we know this will be logarithm, so I can write ln of this whole term, and you have to divide with the coefficient of this v, so that is minus b naught square L square by MR. Now let us put the limit here. So before putting limit, let me multiply this term in the left hand side, which I have done here. You look, so b minus b naught square L square by MR into t. This term I have multiplied in the left hand side with t, and in the right hand side I have put the limits. So lower limit v is equal to 0, so this term will be 0, so you will get ln g, and upper limit, like the higher limit, upper limit, you can put v. Okay, so you will get this term, and if you just simplify a little bit, see this term as it is, and see here I just divide with g, because minus ln means you can just take, you can just divide. Okay, so 1 minus b naught square L square by mgr into v. This is the term now, and in the left hand side you will get this one. Okay, this one. Now I have to find out v. So for that I have to take anti-logarithm. Okay, so I have taken anti-log. So e to the power minus c, e to the power minus b naught square L square by mr into t is equal to 1 minus of this term. Okay, this term. Now I have to find out v. So let us do a little bit of simplification here. So this is, see, finally I get this expression for the velocity at any instant of time. This is for, this is at any instant of time. Okay, this is general expression for the velocity. Any instant of time, as long as magnetic force is not becoming equal to the weight of the rod. Okay, now see, we have been asked to find out EMF at t is equal to 0.2 second. So I'll put this time over here at 0.2 second, and see, all these parameters are given, like m is given as 20 grams, so 20 into 10 to the power minus 3 kg. L is given as 25 centimeters, so 25 into 10 to the power minus 2 meter. B0 is 4 Tesla in SI unit itself, and C, G is 10 meter per second square you can take, and R is given. So if we put all the values, okay, then you will be eventually reaching to this. I am not doing this calculation here, but if you put this, you will come to this situation where you will get V is equal to 2 into 1 minus e to the power minus 1. And in the problem you have been given e to the power minus 1 is equal to 0.4. So 2 into 0.6 here, if you just put here 0.4, so you will get 1 minus 0.4 means 0.6. So you will get velocity at time 0.2 second. Okay, so this is the velocity at 0.2 second. Okay, so we have got the velocity. Now look, the question was we have to find out the EMF at this particular time. Now I have, see, question P. Okay, now I know this is B0 V L. Okay, so B0 we know, right? B0 is 4 Tesla. V0 we have got 1.2 meter per second. So everything I am writing in SI unit, and here L is 25 into 10 to the power minus 2. Okay, so this will cancel with this, so you will get 1.2 volt. Look here, so this option is matching, right? Option 3 is matching with P. Okay, now second thing is magnitude of the magnetic force at that particular time. So what will be the magnetic force? How do you find out magnetic force? See, you can do this. See, Q is equal to, see, Q. In Q, the question is magnetic force on the rod. So magnetic force FB will be I B0 L. So I know this to be E0 by R B naught into L. See, I can put the value. This is 1.2 volt, this is 10 ohm, this is 4 Tesla, and this is 25 into 10 to the power minus 2. So again these two will cancel each other. This will be Newton, since it is force, so this will be 0.12 Newton. Okay, 0.12 Newton, so 4. So this is matching with 4. Q is matching with 4. Okay, so I'll write here P matching with 3, Q matching with 4. Now we have to see R. What is the power dissipation? See, power dissipation I can write, see, option R. Power dissipation is I square. So I square R, let me write first. I square R. I know I is E by R square into R. So E square by R. Okay. E I know 1.2. So I'll multiply 1.2 divided by 10. Okay, 10. So you know this will be 144 divided by 1000. Okay, so you will get actually 0.144. That means, see, 0.14 approximately in watt. So we have got this. Okay, so R is matching with 2. Okay, now last option, that is the find out terminal velocity. We have to write mg is equal to E by R BL. Okay, so see, E again is B0 VL divided by R. So it is actually B0 square VL by R. So V will be mg divided by mgr divided by B0 square into L. So m is 20 into 10 to the power minus 3. Then G is 10, R is 10 divided by B0 square. This B0 square is 4 square, that means 16. This is L is 25 into 10 to the power minus 2. Okay, so here this 0, this 0, this 0, so they will cancel each other. This is 8. Okay, if I take this 10 to the power minus 2 here as 100, then 4 to the 8, 425. So you look here, what do we get? Okay, somehow I have missed one. Okay, so here it will be L square. Okay, this will be L square. So here one more 25 into this will be there. 10 to the power minus 2 will be there. Okay, that means, you know, you get 10 to the power minus 2 will be, so 100 will be there, and there will be 50 over here. Okay, so this will be 2. So V we get 2 meter per second. So this is the answer for the last option. So look here, what is matching with this? S is matching with this 5. Okay, So S is matching with 5. Now we'll see the options. P3, where is P3? So this is P3Q4. P3Q4 R2S5. So option D will be the correct answer for this question. Thank you.
Why waste time in commute and spend a lot of money for NEET UG coaching? Parents, do you want your kids to achieve top scores in NEET? India's leading online NEET coaching, 100% success. NEET UG. TeenEinstein.com. At TeenEinstein, we focus on NEET coaching from Class 6 to Class 12. We think you'll like it. Our teachers are mostly PhDs in physics, maths, chemistry, botany and zoology with lots of years of teaching experience for Class 6 to Class 12. Thousands of videos, quiz, MCQs. We provide a daily worksheet of 30 questions on each topic: math, physics, chemistry and biology for rigorous practice, concept understanding, evaluation, quizzes and thousands of videos. Limited offer 40,000 per year. Book your class. TeenEinstein.com. Contact 99402 49720.